Okay, so the final part of this mini series is about concentrations and how we express the amount of drug we have. So why are they important? So we need to know how much active drug we have in order to know how much we're giving the patient, how much dose the patient has, but also we need to know how to express the amounts of medications and the different ways they're expressed if we come across calculations. So there's a number of ways in which they can be expressed. So there's a solid in solid. So we can imagine perhaps an amount of a powder, part of which has drug. The rest of it is what's called a filler or an excipient. So that would be a weight in weight, W stroke W. We have a solid in liquid. So this is, you'll be familiar with many medications that are available, which are actually drugs within a liquid format. And they are weight per volume. And then we have liquid in liquid. So if you have a liquid drug, then it will be volume in a total volume. So volume of the drug in the total volume. And it's really important that we know the amount of active ingredient contained in a given volume of liquid or solid in order to know what the dose is given to the patient. So how do we express an amount of drug? Let's imagine, for example, that we've got a small amount of drug X, let's say 300 milligrams of drug X. Okay, remember that can also be expressed as 0.3 grams or 300,000 micrograms. They're all the same things, another way of expressing it. But we have this 300 milligrams, and that could be, let's say, for example, it could be contained in 100 grams of a 0.3% weight solid solution in lactose. So in that larger pile of powder is 300 milligrams, and the total amount of that powder is 100 grams in total. So one way to express that is 100 grams of 0.3% weight. We could also say that it's in 500 mils of a 0.06% weight volume liquid solution in water. All of these will contain 300 milligrams of the drug. And what that means is that if we are trying to do a calculation, we are able to know how much of the drug we're actually working out in the calculation. Okay, so let's think first of all about solid oral medications. So tablets and capsules are normally given as the amount of active ingredient per tablet. So let's say paracetamol tablets are 500 milligrams. However, there are also in the paracetamol tablets, there are excipients, which mean that it's heavier than the 500 milligrams, and those are for the production process. And you'll be hearing about that in a different series of lectures. So liquid medicines are usually given in amounts and often expressed as amount per 5 ml. And that's because the 5 ml spoon is the medium we normally use to give it with. So let's say, for example, that we know we have a 15% weight volume solution. So we want to know what dose that is for the patient. We can use this formula that we'll come across quite frequently, C1V1 equals C2V2. So we know that the amount we have is 15 grams in 100 mils because 15% weight volume solution means 15 grams in 100 mil. Now the thing we don't know is the amount that's going to be in a 5 ml dose. And so we can work that out by solving for x, as you can see there on the slide. And that gives us 0.75 grams per 5 ml, which is the dose we'd normally express. because that would be equivalent to a patient taking perhaps a tablet, taking the 5 ml spoon. So this has been very brief, but what you really need to know are amount strengths, so the amount of drug in any product, ratio strengths, how much of that in a ratio with something else. Parts per million is another expression of the way that drugs strength is given. We also have percentage strengths, and those come as percent weight, and that means number of grams per 100 grams. We have percent weight volume, which is number of grams per 100 mils. And finally, we have percent volume, which is number of mils per 100 mils. Those are things you actually need to know. They won't normally be given to you. So in summary, knowing how to work out ratios helps us work out strengths of drug and therefore how much we need to give to enable the patient gets a particular dose. It also helps in calculation in order to always know that we're dealing with the same thing. And as you'll know in calculations, it's always important to know the units you are working in. Okay, so the final inspirational person for this series is Atticus Finch. And again, I'll let you go and find out more about him. He isn't real, by the way.